Hi YouTube, this video is a presentation I recently prepared for Ranty Flat Earth's channel. The audience were mostly flat earthers, so it was aimed at them and not you lovely guys who are already subbed to my channel. If you have seen my video How I Know We Went to the Moon, this is a more condensed version of it. If you haven't seen it and would like even more evidence and detail than I provide here, then please check out How I Know We Went to the Moon. The link is in the description. Enjoy. Thank you, Ranty. Good evening, everyone. During the next 30 minutes or so, I'm going to talk about the Apollo moon landings and show you evidence that they actually occurred as reported. Now, given the audience I face here, many of whom would be happy to tell me outright that space is fake, this is quite a challenge. I don't have time here to talk about pressure without a container or rockets in vacuums. So at first it occurred to me to ask you to forget any preconceived notions you have on this subject and just consider the evidence I put before you. However, I doubt any of us can truly do this, so for the purposes of this event, let us consider that NASA and their Apollo astronauts are well and truly convicted of perpetrating a hoax. They're all serving time in various state penitentiaries, and what I will present to you tonight is an appeal case. Appeal cases require new evidence that was not previously considered. So I do not expect to change your mind on this subject, but can I present enough new evidence that you have not previously considered to get you to reopen and reconsider this case? Let's see. For me, the most compelling evidence that the Apollo moon landings occurred is that we saw it. I'll leave a moment there for the raucous laughter to die down before I point out that I said saw it and not watched it. What many people don't seem to realise is that the Apollo spacecraft were tracked all the way to the moon and back by thousands of earthbound astronomers. Some parts of the space operations were even seen with the naked eye. Not everyone believes that rocket launches actually occur, so let's start there. Each Apollo launch was witnessed by hundreds of thousands of people. They lined the beaches, the roads, and even the rivers surrounding the Kennedy launch site, along with hundreds of thousands of press reporters, photographers, and TV and film crew from around the world. The Saturn V can be seen on TV footage up to an altitude of over 75 miles, which is considered to be in space by any standard. After completing 1.5 Earth orbits, the Apollo spacecraft fired its engine for the translunar injection burn, leaving Earth orbit and sending it on a trajectory to the moon. Soon after, the transposition and docking maneuver began. The command service module separated from the spent S4B booster, jettisoning the 4 adapter panels and exposing the lunar module. It then turned and docked with the lunar module. This made a very distinctive group of 6 objects: the docked spacecraft, the spent booster, and the 4 spinning adapter panels, all travelling to the moon. There are many reported sightings of the spacecraft and some or all of its spent components on its way to and from the moon. Here are just a few examples. Remember, most of the images here are scans from old newspapers, so the image quality isn't great by modern standards. First, from the Smithsonian Observatory in Hawaii, a set of 3 images showing the TLI burn of Apollo 8 as it left Earth orbit. We can see the perspective on the exhaust plume change as the spacecraft passes over Hawaii. In the UK, several amateur astronomers managed to photograph a fuel dump from the expended S4B stage of Apollo 8 on December the 21st, 1968. This photograph, taken by N.J. Hendry of Colchester, shows blowout of excess fuel from the 3rd stage. At the same time, this event was also captured by an observatory in San Fernando, Spain. We can tell by the displacement of the spacecraft against the background stars in each image that the spacecraft was about 30,000 miles from Earth at this time. The Lunar and Planetary Observatory of the University of Arizona shot this image showing the spacecraft booster and some panel reflections. Corralitos Observatory, then operated by Northwestern University, captured over 400 images as they tracked Apollo 8 for the 3 days of translunar coast, providing very accurate locations for the spacecraft. The module is the faint moving dot at the bottom center of these 3 images. In this composite of 2 photographs taken 2.5 minutes apart, we can see the movement of the spacecraft as the stars appear as horizontal pairs while the spacecraft components are shifted diagonally. Daniel Weidman, an astronomer at the McDonald Observatory at the University of Texas, said this as he recorded his Apollo 8 sighting. "Everybody was celebrating reports of Apollo, so I decided to take a look for it. It was easily seen as a moving object in the telescope. I invited all the staff who lived at the observatory and the other visitors who were there to come and look at Apollo 8. It was a wonderful Christmas Eve experience for everyone." On December 27, 1968, the Lick Observatory at the University of California produced live TV pictures of Apollo 8's return coast to Earth, which were broadcast to West Coast viewers via KQED-TV in San Francisco. Here the spacecraft is the leftmost of the 2 bright dots at the bottom of the image, and here it is moved to the top right. A Pan Am flight from Honolulu to Sydney witnessed the re-entry of Apollo 8, described in an article in the Sydney Sunday Telegraph, December 29, 1968. Sky and Telescope magazine, July 1969, features a report on the worldwide efforts to track Apollo 10, which included 15 major observatories and over 100 astronomy groups. It lists numerous recorded observations. And again in the November 1969 edition of Sky and Telescope magazine, which lists many sightings of Apollo 11 both to and from the Moon, including a naked eye sighting from an astronomer in British Columbia, who followed sighting directions that were published in the local paper. Qantas pilot Frank Brown saw the re-entry of Apollo 11 from a Boeing 707 near the Gilbert and Ellis Islands, today Tuvalu and Kiribati, respectively. In the late 1960s, astrophotography was a lot more difficult than it is today. Not all astronomers could photograph their sightings, so some took notes and drew sketches. This series, drawn by 2 UK astronomers, shows an Apollo 12 fuel dump. At the other end of the technological scale, image orthocon TV images from Corralitos Observatory, showing a water dump from Apollo 12 on November the 15th, 1969. The ejected water cloud, marked here with a W, can be seen moving away from the spacecraft marked SC. Numbers 1 to 4 are tumbling SLA panels. These before and after shots from Mount Coban Observatory in Canada show the cloud created by the Apollo 13 explosion. This observatory continued to track Apollo 13 and provided up-to-date positioning data to NASA as they planned the return journey. The re-entry of Apollo 13 was seen by the passengers and crew of an Air New Zealand DC-8 bound to Auckland from Fiji. A report and photographs appeared in the Auckland Star on April the 18th, 1970. One of the passengers took these photographs of the smoke trail left by the spacecraft. There are many, many more recorded observations of the Apollo missions from numerous observers. They come from literally the man in the street, from aircraft passengers, from university students, from individuals and groups of amateur and professional astronomers all around the world. The records show us that objects of the size and configuration of the Apollo craft were sent to the Moon as described. The Apollo missions weren't just tracked optically. There are a number of accounts of amateurs receiving radio transmissions directly from the spacecraft. The first of these accounts comes from a 1960s conspiracy theorist. It seems that distrusting NASA is not a new idea. In July 1969, Larry Basinger, an amateur radio astronomer from Louisville, USA, with a keen interest in NASA, astronomy and UFOs, independently detected signals from the Apollo 11 astronauts on the Moon. His attempt was witnessed by Glenn Rutherford, a reporter from the Louisville Courier-Journal, who published the story in the July 23rd edition of the paper. in an article entitled Louisvillians Hear Moonwalk Talk on Homemade Equipment. Basinger had experience with satellite tracking and had previously successfully received images from weather satellites and printed them on carbon paper using an impact printer. Basinger wanted to independently verify the information that NASA had been providing about the Apollo program and hoped to receive radio traffic that NASA did not want the public to hear. Assisted by Rutherford, Basinger manually sighted his homemade antenna on the moon and was able to hear astronaut voice communications a few seconds sooner than his wife and daughter who were watching the moonwalk on TV. Although this was quite an achievement, Basinger was disappointed that he heard nothing that NASA had edited out. A hobby group at Kettering Grammar School in the UK successfully received transmissions from several Soviet and US spacecraft, including Apollo 17 in December 1972. This Russian website gives an account from E. Molotov, a Soviet technician who was tasked with testing Soviet communications for their planned lunar program using transmissions from the Apollo craft. Using a 30-meter dish in the Crimea, his team were able to receive voice, telemetry and TV transmissions from the spacecraft. Sven Gran, a University of Florida student in 1972, gives a technically detailed account on his website of the Apollo 17 launch that he attended and his team's attempts to track and receive radio transmissions from the spacecraft. Using homemade and surplus equipment, they were able to receive voice and telemetry transmissions from Apollo 17 in Earth orbit, and a few days later from the astronauts on the surface of the Moon and from the command module in lunar orbit. These accounts show that radio broadcasts of voice and data were sent from the Moon at times and locations congruent with published information at the time. 3 Apollo missions deployed retroreflectors on the surface of the Moon. The Soviets also mounted retroreflectors on their Lunokhod 1 and Lunokhod 2 robotic rovers. These retroreflectors consist of an array of corner cube prisms which reflect light directly back in the direction it came from. Scientists on Earth can aim high-powered pulse lasers at the retroreflectors and measure the time it takes for the light from the laser to reflect back to Earth. Here are the results of a lunar laser range-finding experiment. The dots show when photons are received from the Moon. The dark line shows that a number came back at a specific time and hence were reflected by something quite small, well under a meter in size. This concentration of photons at a specific time occurs when the lasers are aimed at the Apollo 11, 14 and 15 landing sites. Otherwise, the expected featureless distribution is observed. These high-precision measurements of the Earth-Moon distance contribute to the foundations of our knowledge of gravitation and planetary physics. Many scientific experiments have taken place which utilize lunar laser range finding. Here are some examples. Since retroreflectors were first deployed on the Moon, many observatories around the world have conducted laser range-finding experiments. The Apollo missions returned 391 kilograms of rock and soil samples. These samples show obvious signs that the rocks were formed on the Moon and not here on Earth. Here is a photo of a terrestrial rock called olivine gabbro under a microscope. The greenish material along the cracks and the brownish material on the edges of the olivine are water-bearing minerals derived from the alteration of the olivine. The feldspar looks slightly dusty, peppered with tiny inclusions, also the result of alteration. Now we see a very similar lunar rock. What leaps out in comparing the two pictures is the complete absence of water-bearing minerals and the total absence of alteration in the lunar rock. Water is everywhere on Earth. It is present in magma. Rocks deep in the crust are changed by hot fluids, and rocks near the surface are altered by surface water. Olivine in particular is easily altered. In the second picture the olivine is fractured, but the fractures are absolutely clean. You simply do not see unaltered olivine on Earth. This could not have been faked. The rocks have grains easily visible to the unaided eye, which means they cooled slowly. To have made these materials synthetically would have required keeping the rocks at 1100 degrees centigrade for years, cooling them slowly at thousands of pounds per square inch pressure. It would have taken years to create the apparatus, years more to get the hang of making the materials, and then years more to create the final result. Starting from Sputnik 1 in 1957, there would not have been enough time to do it, and you'd have to synthesize several different types of rock in 100-pound lots. And the results would have to be convincing. NASA distributes over 400 samples a year to research scientists and educators around the world. NASA's Curation Lunar website lists thousands of samples from all of the Apollo missions and includes descriptions and microscope photographs. Researchers can request samples on loan, including samples of pristine material, and then subject them to any non-destructive tests they choose. This could include, for example, X-ray examination to determine the chemical composition. So faked specimens would have to stand up to any kind of scrutiny that researchers might give them. Whoever came up with the faked specimens would have to have devised a story of lunar evolution to fit the samples. The story would have to have checked out in every detail. For example, rare earth element abundance and evidence of meteor impact. Why create absolutely water-free rocks? At the time, nobody was expecting that. It would have been much easier to fake rocks with water in them. For one thing, you could use terrestrial rocks, and nobody would have been suspicious. And you'd have to put in exactly the right amount of radioactive elements and daughter products to get the rocks to date radiometrically at 4 billion years old, older than any terrestrial rocks. You also have to anticipate the development of new dating methods not in use in 1969, and make sure that those elements are present in the correct abundance. And it's not just like adding carrots to a stew either. To mimic the results of potassium-argon dating, you have to add inert argon gas and trap it just in the potassium-bearing minerals, and in exact proportion to the amount of potassium. Then the story has to stand up to scrutiny for decades, even in the face of new research methods not in existence in 1969. For example, when lunar meteorites are discovered in Antarctica, they have to match the Apollo samples. If you believe NASA has the technical ability to pull all this off, going to the moon is a piece of cake in comparison. This list of well over 100 investigators who were to receive Apollo 11 lunar rock samples is from the Apollo 11 press kit, pages 220 to 241, and only includes those investigators who put their names forward as at July 1969. Ultimately, there were more. The following countries received rocks for research in 1969. Since then, lunar rock samples have been used in research all around the world. I would just take a moment to dispel a few myths about this bogus moon rock from the Netherlands. Contrary to the Flat Earth narrative, this was not presented by Neil Armstrong, and it was not presented to the Dutch government. It was actually presented by the US ambassador to the Netherlands, William J. Middendorf II, to Willem Dries, an 83-year-old former Netherlands Prime Minister. Dries's grandson believes his grandfather formed the mistaken impression that the rock was from the moon because the Apollo astronauts were visiting the Netherlands at the time. No one from NASA or from the Dutch government has ever claimed that this specific rock is from the moon, although it was insured as a moon rock and displayed in the Netherlands Rijksmuseum for over a decade with its original presentation card, which also does not state that the rock is from the moon. Eventually the rock was spotted by an Apollo geek who realised that the presentation date was too soon after the Apollo landing for it to have been an actual moon rock. Ultimately, the only person to ever claim that this rock was from the moon was an 83-year-old man in the last years of his life. Although there have been no manned missions to the moon since Apollo, there have been a number of unmanned missions which have completed detailed exploration of the lunar surface. These include China's Chang'e 1 and 2 orbiters and Chang'e 3 lander, India's Chandrayaan-1 orbiter, Japan's Selene orbiter, and the most impressive, NASA's Lunar Reconnaissance Orbiter. Each of these spacecraft has revealed previously unseen detail which verify the Apollo missions. Lunar Reconnaissance Orbiter images haven't just captured the Apollo lunar modules. Many other spacecraft have been located, including the Apollo S-4B boosters, which were crashed into the Moon as part of the seismology experiments, and a number of other spacecraft from the USA, the Soviet Union and China. Now let's take a closer look at a landing site and see how imagery of it from different sources matches up. For this we are going to return to Hadley Rill, landing site of Apollo 15. Before the Apollo missions, lunar mapping images came from the 5 unmanned lunar orbiter spacecraft. These were used to create maps and in the landing simulator. This is the best quality image of the Hadley Rill area before Apollo. It was taken from Lunar Orbiter 5 in August 1967. Zooming in on a section of the image, we can make out craters, but the detail is limited. In this video, produced by Gone to Plaid, we can see the 16mm film of the landing from inside Falcon, the Apollo 15 lunar module, alongside imagery from Lunar Reconnaissance Orbiter overlaid in Google Moon. The audio is the original transmission from the spacecraft.
20 feet. 100 feet, 3.5 down, 9 forward. 5%. 185. 75 feet. Car's looking good, down a half. 6 forward. 60 seconds. Lights on. 6. Down 2.5.
From this video we can see every single crater and rock in the LRO imagery matches that from Apollo, and we also know that this level of detail wasn't available before Apollo. Here is a comparison of images from Lunar Orbiter, Apollo and Lunar Reconnaissance Orbiter. We can see how little detail was available before Apollo. This still frame is taken from the landing film just before landing, just as the dust starts to be blown up. I have marked the prominent features with coloured arrows for comparison with an LRO image of the same area. As we can see, these details match and could not have been known at the time without getting very close to the Moon. Speaking of dust being blown up, it's worth noting at this time that the Lunar Reconnaissance Orbiter image clearly shows a lighter area around the lunar module. And this area is also visible in this image from India's Chandrayaan orbiter, and in this image from Japan's Selene orbiter, where we can also see the darkened area around the LSEP and the faint hint of a path between it and the lunar module. This image was taken from Apollo 15 itself. The command service module was equipped with a mapping camera which captured this photograph on the 27th orbit of the Moon at 23:52 and 54 seconds on the 31st of July 1971. This was at the end of the first EVA. When we zoom in on the landing site and compare it with the LRO image, we can see that the only trail visible in the Apollo 15 image is the one leading to the LSEP, exactly what we would expect to see at this point of the mission. If we zoom in very close, we can just make out what appears to be an object casting a shadow just to the northwest of the lunar module. And we can see what this object is in this photograph, taken at the end of the first EVA. The lunar rover parked next to the lunar module. This photograph, again from Apollo 15's mapping camera, was taken earlier than the first on the 14th orbit of the Moon at 2:12 and 23 seconds on the 31st of July 1971, around an hour before the first EVA. This time we can see the lunar module with no trail from it, no rover visible, and a longer shadow as we would expect to see for this time. There are a couple of nice oblique views of Hadley Rill, again from Lunar Reconnaissance Orbiter, taken from different directions, and the overhead view we saw earlier. These all show good detail of this small collection of craters on raised ground known as the North Complex. This was explored and photographed by the astronauts, so we can compare their photographs from the surface with the Lunar Reconnaissance Orbiter and other orbiting probes. This is also a good opportunity to make a quick point in passing. This is a photograph of the North Complex, and this is a photograph of another part of the North Complex, both taken by astronauts. This is a composite of photographs showing all of the North Complex. The fact that we have composited two photographs to make this image in no way invalidates anything that it depicts. Just saying. Here is a comparison of the Lunar Reconnaissance Orbiter views and the surface views with arrows to highlight some features. Once again we see everything matches perfectly. This is another panorama composite of Mons Hadley taken by the Apollo 15 astronauts. And this is an overhead shot of the same area taken by India's Chandrayaan-1 probe. If we zoom in on the marked area, we can pick out some details and compare them with the astronaut photos. Once again, fine details that could not have been known in the 60s without visiting the moon are verified by recent non-NASA probes. This oblique shot of the same area comes from Japan's Selene orbiter. Although we can't make out fine details in this one, we can see the topography is an exact match for the astronaut photograph. Indeed, it seems whatever details we test by verifying against other sources, the Apollo photographs and accounts check out. To really hammer this point home, let's take a quick look at one of the most enduring images of the Apollo missions, Earthrise. Taken on Christmas Eve 1968 by the crew of Apollo 8, the photograph we know so well was actually the second of a pair. The first photograph taken was this black and white one. The crew switched to a colour film when they realised the importance of what they were seeing. The photograph has been used in the media many times. Here are a few examples, so we can see that the image we can download today is the same as it was directly after the mission. The photograph was taken as Apollo 8 was flying over a large crater on the eastern limb of the moon called Pasture. This area can only just be seen from Earth and always at a very oblique angle, so the details we see could not be known without visiting the moon. If we zoom in on the crater in the right foreground, we can pick out some details and again compare with China's Chang'e 2 and Japan's Selene orbiters. As we can see, the streaks and markings on the crater wall are exactly the same in each image. We can repeat this with the crater on the right of the image, and again the details match. It's also worth noting that both craters appear in the black and white image, only this time they are further into the background, as we would expect with this photograph being taken just before the colour one. As the crew were approaching the point where the Earth would be visible, they had been photographing the lunar surface using a camera fixed in a command module window and operating on a 20-second timer. It was as they began a roll maneuver to change the orientation of the command module that they first saw Earth. The timing of this maneuver is recorded precisely in the mission, and if we look at the images being taken at the time, plotted on Google Moon, you can see the effect it had on the photographs. I have added coloured borders here to make it easier to see the change in orientation. The timing of the photographs is well documented and can be found in the Apollo Flight Journal. From this data we can plot where they were above the surface and derive a distance between those 2 points. Apollo 8 was orbiting 112 kilometers above the surface, which when combined with a lunar diameter of 3,474 kilometers gives an orbital circumference of 11,618 kilometers. The time between loss of signal on orbit 3 and the same point on orbit 4 is 1 hour 58 minutes and 36 seconds. This equates to a speed of roughly 1.63 kilometers per second. The time elapsed between the first black and white photograph of Earthrise and the first colour one is 53 seconds, which means that they will have covered around 86.5 kilometers between the two. I measured the distance in Google Moon at 84.82 kilometers. Not an exact match, but close enough, I hope. We can recreate the two shots in Stellarium using the correct times and dates, and we can see the position and orientation of the Earth matches the photographs. Zooming in on the Earth, we can see the terminator line and the continents in daylight are a match too. The S7 meteorological satellite, launched on October 2, 1966, for the US Department of Commerce, produced cloud maps daily for the northern and southern hemisphere. These were published for public use and could even be received directly from the spacecraft by suitably equipped amateurs. They were used by meteorologists around the world for weather forecasting.
If we check the cloud maps for December the 24th, 1968, once again we find a perfect match for what we see in the Earthrise photograph.
Now, of course, you can hand wave all this away and say, well, of course NASA made their photos match. But with the Chinese, the Indians, and the Japanese, how was this achieved? And is this the NASA that you know and hate? Aren't they supposed to be blundering around making America too big and shadows point the wrong way? And yet, as we have seen, even the 1960s photographs show an absolute attention to detail if this were a hoax. We have seen multiple witness accounts and photographs of the Apollo spacecraft in flight, technically detailed accounts of successful radio tracking attempts, lunar laser range-finding experiments conducted daily all around the world for the last 50 years by professional astronomers, university and high school students, confirming the location of Apollo experiment packages. Distinctive lunar rock samples with features unique to lunar formation and impossible to create on Earth, available to anyone who genuinely wants to study them, and every year since the 1970s, hundreds of people have done just that. And photographs with fine detail that match every source we check, even as new ones become available. That's my evidence. Hopefully you saw something that you haven't seen before. Can you still tell me that I just haven't researched it? Or maybe now that you have seen some of the fine detail that is freely available to all, you have some work to do yourself to explain how all this was achieved and continues to be achieved if it was all faked. Thanks for watching. I'll be happy to take any questions if anyone is still awake. Thanks, Ranty.